Thank you.
There we go. Okay, yeah, I will move our parachute slide back to where it was supposed to go, just to give you a little look. Somehow our slides got a little moved around before this meeting, but
That's okay.
this is just
all
what our Drogan main parachute looks like. These are both, the images are ones that we've made over the past year for those disc band, and just, again, a kind of a table of all those values that I said earlier. We did do a lot of testing for coefficient of drag on these parachutes as well, so we're pretty confident in the expected descent speeds that we're going to be getting, as well as just the construction quality of these parachutes. But anyways, back to ejection charges and deployment of parachutes. I was saying that the main charges, those ones are a little bit larger size just due to the very large internal volume that our payload and main parachute are taking up. However, we are planning on doing a lot of ground testing of all of our ejection charges, just to make sure that we have sized them appropriately, that they're not too big or too small for that matter. And so we'll do all those here in Minnesota before we go down to the launch site. And so where all these kind of electronics are housed are in between our parachute, our drogue parachute, as well as the payload. So it's in the coupler between our two sections of body 2. Okay, so then moving into the handful of payloads that we have on board. These first two ones, our SRAD Avionics and our Pitot tube, are not the ones that we are using for the actual STL payload challenge. They are just ones that we are flying, I guess, for fun. Starting first with our SRAD Avionics stack, which we call our Universal Flight Computer. This has been in development on our team since about 2020. What it is it's a modular flight computer. So it's a whole bunch of stacks of individual PCB cards that are connected with a common backplane. Each of these PCB cards have a specialized function, such as a sensor card, power card, radio card, or really anything else that we can dream of. The idea here is that this is a reusable flight computer from year to year, where all you need to do is switch out cards, add them, remove them, kind of based on the needs and the flight profile of the vehicle. So this will sit inside the nose cone and is purely for data collection and analysis. We don't have any pyrotechnic devices or events hooked up to this flight computer. It's just data collection and post-flight analysis for our team. We also then in the nose cone, or on the top of the nose cone rather, have our 5-hole pitot tube. So this is also manufactured in-house, made mostly out of aluminum. There are a few other components in the internals which are made out of like brass for connectors or some copper tubing. So this is mounted using a pretty standard nose cone attachment technique that you see in all COTS nose cone devices, sort of that kind of clamping mechanism where we have a disc on the inside, the nose cone on the outside, and we kind of tighten them together so that they fit securely on the nose cone. So this will be used for data collection for angle of attack, angle of side slip, and static pressure data. And then all of this data can be fed into our universal flight computer for collection and analysis post-flight. We have done a lot of simulation with our Pitot tube just to make sure that it won't interrupt the flight profile at all, as well as done a lot of calibration with a local company, Collins Aerospace, at their facility in Burnsville, just to make sure that the data we're getting is actually good data. And so then finally, we move into our actual payload that we're submitting as part of the STL payload challenge. What this payload is, it's a scientific quadcopter that can autonomously be deployed upon landing. So what that looks like is it's recovered fully with the rocket. It stays with the rocket the whole time. And then once it lands, it would be able to rotate, open up its case, as kind of shown in that image on the right, and have the arms of the quadcopter pop out and have the payload take off. The purpose of this payload is to aid in recovery, reconnaissance operations, kind of to survey the land, collect data on the surrounding landscape, as well as theoretically to aid in recovery operations. So how this would be connected to our rocket is connected onto the shock cord and pulled out with the main parachute and recovered, as I mentioned, with the rest of the rocket. So there won't be any flying quadcopter while the rocket is still in the air. It won't be detaching from the rocket in any way. However, in the recent weeks, we have decided that we are opting to not have the quadcopter fly once it lands, just kind of in the interest of safety. There's a few unknowns, out at spaceport. We don't know if there might be people in the surrounding area. So kind of in that interest of safety, we are opting to keep the payload secure inside the rocket, just so that there isn't any concern of anybody running into it post-flight or anything like that. But we still do intend to have it fully operational to complete its mission. So that was just kind of a really brief overview. We wanted to leave it most of this time for you to be able to ask any questions that you have about our rocket. So yeah, I'll turn it back over to Gavin and we can get started with any questions or comments that you have on our rocket.
Okay, whoa, just stay right there for a sec.
Yeah.
Go back one slide. Okay, did I hear you correctly? You do not plan on deploying the copter at all?
Yes.
Yes. Yeah. So there's a few reasons for that. One of them was just like the general liability and insurance that was required to fly these drones at spaceport that we found out in the middle of the year. We opted not to try and pursue all of that insurance and getting all of those appropriate licenses and certifications through the university and the FAA. So that's one of the reasons. But then, yeah, like we mentioned, we just don't want anybody in the off chance, like a recovery team is nearby where a rocket lands. This quadcopter would be autonomous. And so we want to make sure that we would have like eyes on our vehicle or eyes on the quadcopter when it's flying, and we can't necessarily guarantee that.
Okay. I guess the next thing I want to do is I want to go back to the SRAD motor. So whoever,
Yeah.
well, actually, go back down to recovery for me just real quick.
This one here, or do you want the next one?
Next one. Okay. Any idea why? I'm curious as to why 3 pieces of electronics
Yeah.
for deployment.
Yeah, so that's definitely a question we've been asked before. I think it partly due to the fact of, I mean, I don't love this answer, but that's the way we've always done it. And one of the reasons why that's the way we've always done it is because, you know, when our team was existing 4 or 5 years ago, they were very concerned about redundancy. It's kind of a leftover of like, we have the room, we have the weight. Why not have an extra flight computer? Like last year when we flew, one of our flight computers just didn't record any data. And so if that happens again for some reason, you know, we have different ones, they're new this year. But if that happens again, just having 2 other flight computers that have data that we can collect and analysis post-flight, ones that we can ensure that we can get the recovery tent after flight, a good reading of our altitude is part of the reason. And also just to kind of better be able to control 3 separate ejection charges as well.
Okay. Do you know if the team has looked at using CO2 in place of black powder at that altitude?
Yeah, we have looked a little bit in CO2 for this rocket as well as our high altitude ones. There's a few reasons we haven't pursued it as much. Partly is just there's a larger kind of startup cost, and we are quite familiar with using black powder charges, so it's just kind of a favoritism at that point. But also, we take a lot of advice from our mentor Gary, and he's used CO2 ejections a lot, and it's just his experience has told us that getting a good seal is sometimes a little bit more challenging. And so we like the black powder, how fast it burns, how quickly it can build up that pressure to ensure that there's enough pressure to shear those shear pins and separate the rocket.
Okay. Can you go up one slide for me? Yeah. What's the length of your recovery harnesses?
Yeah, so for the drogue one, it sits about 55 feet, I believe, and then the main one is 69 feet.
Okay. All right. Let's see here. Where do I need to go next? Back up. Next is the SRAD motor.
Yeah, so I'm gonna invite Nels up here. He's our propulsion lead to talk a little bit more about that one.
Yeah, I kind of figured. Thank you much.
Okay. Well, I'm a little tall for where the camera's sitting, so there's that. That's good. Hi, Ben. My name is Nels Erickson. I'm the propulsion lead on the team.
Nice to meet you, sir.
How can I help you?
Look forward to meeting you at the contest. Can you back up to the one slide before that? Okay. Tell me what you changed between what you submitted in report 2 versus what you have here.
There should have been little to no change between what was included in report 2 and what we have here. If anything, the change would have been simply in the way that the data is presented. If we had submitted something different in report 2, that would have been an error.
Okay, because what I have from report 2 is an 05375, give or take a little bit, I think.
So what I will say is it's possible that for report 2, some of the data that was submitted was from the simulated results as opposed to the hot fire results, but the data that's shown here is from our static fire.
Yeah, so it looks like I think we mistyped our average thrust in the report as well as the burn time to be from our simulated data rather than having our actual test data on that report.
That's not cool, folks. Um, okay, the data that you sent with report 2, then it's not the true hot fire data?
Well, no, the data that's included in that ENG file should be, there should be a, yeah, the sorry, not the ENG file, but the hot fire test results. It's an Excel sheet that was submitted with report 2.
Okay. I'll
That
double check.
is the data that is
That-
what was recorded.
So on the spreadsheet, I have all these times and voltages and newtons and all that sort of stuff. What does that represent?
That's on code sheet 1. So as you'll see, we have 4 different groupings of the data on that sheet.
Mhm.
So there is the raw data that's recorded by our data collection system. And then essentially what we've shown in the sheet is we show the evolution of how we take that data and get it to the point that we produce the thrust curve that's shown here on the slide. And so you've got raw data and voltages from our data collection system. We then zero it, still keeping the collected data in the raw voltage that we achieved through the analog instrumentation. We then convert that using the instrumentation's calibration curve to newtons. And then we then continue to process the data to sort of clip out any transitory information from, setup such. And then we provide at the end is both an unsmoothed and a smooth data set.
So to net it out, then the first 2 columns on that spreadsheet, columns A and B, are the actual test data.
Correct.
Okay, that makes me feel better. All right, you don't have a pressure transducer.
No, and so we had when we had tested this motor, we were not aware that Ezra would be requiring pressure data this year. It had not required pressure data in years prior, and so we had used some of our academic year downtime to perform this hot fire test. And so because we didn't have this data, we didn't have the knowledge that we would be required to submit pressure data. We had talked with Ken Overton, and he had basically given us permission to extrapolate pressure data from our thrust data, just using the rocket motor equations. And
Do you
so,
have a copy? Do you have a copy of the email that confirms Ken's conversation?
yes, and we can forward that to you
I
here at right after the meeting.
I would appreciate that. And by the way, yeah, so for planning next year, we will require pressure.
Yes, and we're already working with our, within the propulsion group, we're working with our motor testing and data collection leads to get all of that instrumentation set up and ready to go.
Cool.
I will say we do record pressure on some of our smaller scale motors. It's just that we didn't have the proper interface equipment to allow that pressure transducer to be used on our larger scale motors.
Okay, cool. Do you know what your max pressure was?
Yeah, so you can see here peak pressure from the converted data. So converting the thrust data to pressure data using the rocket motor equations, we calculate it to be about an 896 psi. Simulated, I believe our max pressure was simulated to be about 803 psi.
Then why in the spreadsheet you sent me with pressure, the max PSI is 1,864?
That was, we had made a mistake in our math, and again, that was a human error. I can provide the calculations as well in an email to show you the corrected mathematics.
Guys, you really need to keep us in the loop. If you make mistakes, we need to know it. All right. Yeah, I want I guess whatever spreadsheet you sent me, Charlie hard fire test results, please send me the correct information.
We'll take care of that as soon as this meeting's finished.
Okay. And the reason I'm kind of being a little bit on the rough side on this is an O going to 30,000 feet. You're within 90%. Not much wiggle room before you get to a peak. And we have to be very careful not to get to a peak. Okay, because that's a totally different class of rocketry, and we do not support that. So these SRAD motors and the test stands and the data needs to be dotted, crossed, and so on and so forth. Okay. That's must be a lot of mistakes in some of this stuff.
Yeah, also, Ben, I'm not sure if you had the chance to look, our technical report does have all that updated information as well that we submitted last week. But we'll still send you that updated spreadsheets and stuff as well.
Yeah. Okay. And I'm very familiar with how Ken backed into pressure from thrust, so that's very straightforward. Okay. All right, let me see here. What else do I need? Okay, it's time to look at the rocket.
Right, so I'm gonna pull up webcam on my side. Gavin, do you want to stop sharing your screen maybe?
And can we also go on ahead and just close the slides out? That way I'll be able to see things better.
Yep.
Thank you.
All right, so I'm gonna go ahead and start the video on my side here. So let's get a little bit further back here. So we can, yeah, that would be good. Thank you, Nels. Kevin, you want to move that chair out of here? It's like we might even just need to move it a little bit further back. So we got our main tube booster, our booster section here. All this here is carbon fiber with the carbon fiber pins on the bottom there.
Okay.
And then next to it here, we have the upper section of our rocket. So we have the fiberglass body tube below kind of where my hands are sitting here. And then on the top half, we have our fiberglass nose cone. And then those two sections, the booster and the upper body tube are just coupled together. Fiberglass cone.
Okay. Yeah. Okay, go ahead. That's it.
Here's the pitot tube, which sits on top of the nose gun. We have it off for easier display, but it does fit.
Okay. All right. Can I see your shot cards? And your parachutes?
Yeah, we'll start with the parachutes. We gotta go run. We're not in our lab space right now, so we're just gonna run downstairs, grab that. And start.
I just want to confirm that there are no holes in the parachutes.
Okay, do you want to bring it over?
That the shot cords aren't burnt up.
Yep. Yeah, so here's our parachute. If you can kind of see that, the only holes that are in there are the ones that are supposed to be there for
You're
the
fine.
gap.
Yeah, I can see it. You're fine. Okay.
Yeah. Do you want to see the main parachute as well?
Yeah. Just tell me. I just no holes. It's in good shape.
Oh, it's good. Yeah, it's kind of a big one.
Okay. Shot cords.
Shot cords, he's running out and get those. If we want to come back to that, we can show you any of the other stuff that you want to do.
Okay. All right. What I'm trying to do, what I'm trying to make sure of is that in the past, teams have arrived with shot cords that basically you could almost pull apart. You know, because they did a bunch of ground testing or you used 2 years ago or whatever. So if that's going to happen, you're going to have to go buy new, excuse me, new shot cords in order to fly.
Yeah,
so I just want to make sure we get that out of the way before you get there.
Yeah, good call. We are using all new chute, shot cords, suspension lines. All of it is brand new. Like,
okay, if you're telling me that you're using all new stuff, that's great, and that's fine. That's one less thing to worry about. on that end of it. Okay, at this stage of the game, I'm okay with what you, oh, here she comes. I'm okay with what I see so far. Have you already mixed the contest motor?
Yes, we have it mixed. It is in our lab. Currently in our, propellant storage area. It's a secured cabinet that's rated properly for storing that type of material.
Okay, cool. One less thing to worry about.
Yep.
Okay. At this stage of the game, I'm happy with what I see. I'll reverse the tables and say, do you have any questions for myself that concerning the contest or whatever? And I guess to a certain extent, I apologize, but one of the things that teams need to be aware of is the contest rules are somewhat dynamic and they will change. So never assume that the DTAG is the same as you read last year. Requirements will change from year to year. So this is, yeah. Anyway, questions for me?
Okay, yeah, so we have just a couple here that we have on hand that I'm going to kind of go through. The first one is kind of surrounding check-in day of the competition. So our mentor, Gary, is the mentor for our team, but I'm going to be the flyer of record for our rocket. However, Gary is also the flyer of record for a different team at the competition. So there was that form that was sent out like last week to all the competitors saying, send this to all of your mentors that aren't like students on the team and stuff. And so he filled out with us as his primary team. But is there anything that he needs to otherwise do, or should we have him do just to make sure that like check-in goes well, that they recognize that he's the flyer of record for another team, even though kind of his primary team is us, where he's just the mentor?
That's a good question. Let me think. First of all, let me ask you a question. You are level 3.
Yes.
Okay, because just as a general comment, and it sounds like you're up to date on it, is that nobody can go out to the pads unless they are a member of Tripoli. And the only person that can handle the motor is the person that's the flyer record has to be certified to the level of the motor. So you've got that covered.
Yep. Yeah, and we have all our members going, or at least Tripoli members as well. So not concerned there.
Okay. I think probably the best thing for you to do is send an email to Andy, who is the vice president, and ask your question, because he's the one that's in charge of the badging and he knows how it's all going to work.
Sure. Yeah, we can do that.
Okay. Yeah, he should get back to you relatively quickly. So I don't think you're going to have 2 badges, but I don't know how they're going to manage it. The way they're doing it this year is that there's Rocketeer badges, there's mentor badges, there's FOR badges. Okay, so and I don't know if they're gonna put the team name on the FOR badge or not, or exactly what they're doing. So, but he would be able to give you an idea of what's coming down.
Sounds good.
Okay. Anything else?
Yeah, we got a couple more here.
So could you tell us a bit about the process for payload at the competition? Like when and where payload checks will be?
As far as I know, there will be, you'll have your display. There'll be judges come by and ask you questions about the payload. That will be on Tuesday, I believe. Monday, Tuesday timeframe. Then at the field, your payload is checked in an area that's marked for payload, where they weigh it and so on and so forth.
So pretty similar to the process last year, it sounded like.
Yes, really. Yeah, exactly.
Okay.
Yeah, no different.
Also on the payload, is there going to be opportunities to show functionality to the judges? Since, we have a quadcopter, is there going to be times where they want us or expect us, or we can give the opportunity to fly it, or not as much?
The judges are the payload judges or the rocket or the contest judges?
The payload judges.
I would send an email off to SDL and ask them. Unfortunately, I'm dealing only with the contest and the rocket flights, and payloads being managed by SDL. So
Sure.
Um, I really don't know too much about it, so,
Yeah, if it's easier, we can also just send that question on the payload form on HeroX.
yes.
Okay.
But
Yeah, we can,
response time's not, and SDL does have a section on HeroX that you can ask questions of, so. I don't know
Sure.
how responsive they are, but yeah,
that's good. We can look further into that on HeroX.
okay, all right.
We got a couple other questions here. One of them is we're wondering if you know when the podium presenters will be released, like what teams are going to be presenting at the competition.
No, I do not.
And then, what days will the FRRs be on? Will it be starting again on check-in day Monday, or is there a change in that? There was some confusion last year, so
No, there's no change in that. So your flight readiness reviews or safety reviews will be just like they were last year.
I think the only other one is, a lot of us just last year is the kind of only basis we have for the competition, since other years kind of our school year were either canceled or virtual. Are there any other significant changes to like how the competition is operating or running or other logistics to it that we should be aware of, just so we kind of know what to expect there?
We've obviously made some updates. I believe there are now 30 solid pads. Hybrids and 2 stagers have been separated off. So we shouldn't have the overlapping problem that we had last year.
Okay, that's good to hear.
The award ceremony will be in a different spot than it was last year. Much beyond that, the contest itself is basically the same. I think the point spread is about the same. The other differences being things like AAA requirements for membership for FORs and so on and so forth. That's a change. The layout is basically the same. Not much different from that. We do have more sponsors this year that we're expecting, which will be nice for bringing your resumes. Hint, hint. There'll be an on-site vendor for sure. Beyond that, I think that's a pretty good summary. Prepare for anywhere between 90 and 110 degrees. Winds anywhere between 0 and 20. Hopefully it won't rain. Hopefully that's not
Yeah.
coming this year.
Yeah.
That
We
did
hope
throw a
so
lot
as
of-
well.
Yeah, that threw a lot of wrinkles in. The number of teams right now that we're doing the initial safety review on is somewhere around 140. So it could be 40% bigger than last year.
Wow,
So,
that's exciting.
so hit registration early.
Is there any kind of formal check-in process for registration, or is it kind of just show up as early as possible and wait in line?
Yeah.
Okay.
Yeah. There's no, no, there's no pre-plan for that other than I'm sure it's going to be just like it was last year. From
Sounds
that
good.
perspective anyway. And I think this year, all of the members of the team have to be there. So they can get their badges and everything and consents, and make sure you've dotted all the i's and crossed all the t's and all the paperwork, the waivers and all that sort of stuff that had to be signed and
Sure.
delivered, so. But rocket looks excellent. The motor's fine, pretty straightforward motor. Let's be a little more careful on our testing and stuff and make sure we get the next year when we request the same thing again, we actually wind up getting what we really need.
Yeah, we'll definitely kind of make sure more of that's lined up as we move forward.
Yeah, and again, we're looking really hard at 30K SRAD. Because we don't want to go over, we don't want to exceed our waiver. And the last thing we want is for this motor to wind up being a P and not a no, so.
Just curious, what is the standing waiver for the competition? Like, I know there's, I think, one exhibition flight. Do they have much higher than 30,000 feet to work with?
No, with the waiver, I don't even think I'm trying to think, we might have an exhibition flight this year. The waiver, our waiver has been cut way down. And that's been due to a couple of things. One is basically new management at Spaceport itself. And over the last couple of years, there have been a couple of accidents where rockets have landed over in White Sands. And that's not good. They're not happy about that.
Yeah.
And as a consequence, FAA, Spaceport, and White Sands, and everybody got involved in it. And they basically saying, yeah, you got to cut your waiver down. So. And then bringing in Tripoli for the insurance purposes and all the other stuff, that also has an impact on the waiver and how you can fly. So. But I think it's all for the good. I mean, you know.
Yeah. Yeah, that makes sense.
You know, it doesn't take much to take an Air Force base off. Believe me. So anyway, like I said, hopefully it won't rain. That's the only thing we'll hopefully miss from this coming versus last year. So
Yeah, we're definitely hoping for that as well.
any more questions or?
I don't know, does anybody else of our team members in the audience have any questions? I think we're all good on our side, unless any of our team members on Zoom have any other outstanding questions.
Did what now?
Just kind of checking in with all of our team members. I think,
Oh,
yeah, I
okay.
think we're done with all of our team members' questions here. So we should be good to go. We'll make sure we get you those couple updated propulsion data sheets that we had talked about earlier. Yeah, I think that's it.
Yeah.
And how would
Go
you
ahead.
like would you like us to send the recording to you?
Yeah, if you can, put it up on a shareable drive and send me a link to the shareable drive.
Okay, sounds good.
That will work best. We can stop the recording.
Okay.